Today, we are going on an incredible journey through our cosmic neighborhood. Yep, a grand tour of the solar system. You can kind of think of it as the ultimate family road trip, with our sun in the driver's seat and a whole crew of planets and moons tagging along for the ride. So, are you ready? I hope so. Grab your imaginary space helmet because we are about to blast off and explore everything from our blazing hot star to the iciest, most distant worlds. Let's do this. Okay, so our first, and you could say most important stop, has to be the heart of our system, the sun. It's our gravitational anchor, it's our cosmic power plant, and it's the very reason life exists here on Earth. I mean, without it, there's no solar system. Simple as that. So what's with this number? Well, that is the sun's share of all the mass in our entire solar system. Yeah, you heard that right, 99.86%. Every single planet, every moon, asteroid, and comet, all of it combined makes up just a tiny little fraction of what's left. The sun is, without a doubt, the titan of our cosmic neighborhood. So what is this giant star even made of? Well, it's basically a massive ball of gas. About 3/4 of it is hydrogen, and most of the rest is helium. This specific fuel mix is exactly what powers the sun's engine through a constant, crazy powerful process called nuclear fusion. And let me tell you, that engine is unbelievably powerful. At its very center, the sun's core hits a temperature of 15 million degrees Celsius. It's that immense heat and pressure that smashes hydrogen atoms together to make helium, releasing all the energy that travels for 8 minutes through space just to warm our planet. Just incredible. All right, so now that we've met our star, it's time to visit the planets. And to keep our travel plans straight, we're going to use this handy little phrase. It gives us the first letter of each of the 8 planets, in order starting from the sun. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So let's kick things off with our first group of destinations. We're starting close to home, right near the sun, with the 4 small, dense, and rocky planets that make up the inner solar system. First up, we've got tiny Mercury, the smallest of them all, with no moons to its name. Next is Venus. It's the brightest planet in our night sky, but don't let that fool you. It's also the hottest. Its atmosphere is just crushing. Then, of course, there's us, our home, Earth, the blue planet, totally unique for its liquid water and, life. And finally, we have Mars, the famous red planet, which gets its color from all the iron oxide, basically rust, on its surface. Okay, buckle up, because now we're taking a huge leap outward. We're crossing a major boundary in the solar system to go visit the colossal planets of the outer system. Welcome to the realm of the gas giants, which are on a completely different scale. First is Jupiter, the undisputed king. It is the largest planet by far, famous for its great red spot, a storm that's bigger than our entire planet and has been raging for centuries. Next up is Saturn, known for those stunning rings and for being so light, its overall density is less than water. It would literally float in a giant bathtub. Then we have the oddball, Uranus, which probably got knocked over by a massive collision way back when, causing it to rotate on its side. And last on our planetary tour is Neptune, the farthest and windiest world, just a deep blue orb with supersonic gales. But hey, it's not just about the planets, right? The tour isn't over yet. There are countless other fascinating objects orbiting our sun, and every single one of them has its own story. Remember that boundary we crossed between the inner and outer planets? Well, this is it, the asteroid belt. It's this huge ring of millions of small, rocky bodies, pretty much the leftovers from when the solar system was first forming. Now for the icy visitors, comets. They're essentially cosmic snowballs made of ice and dust. And as they get close to the sun, they heat up and start releasing gas and dust, creating that spectacular tail. And that tail is pushed by the solar wind, so it always points away from the sun. The most famous one, of course, is Halley's Comet, which pays us a visit about every 76 years. Okay, let's clear something up that trips a lot of people up. So while a small rock is just floating around out there in space, we call it a meteoroid. When it hits our atmosphere and burns up, that streak of light you call a shooting star, that's a meteor. And if a piece actually survives that fiery journey and lands on the ground, that's a meteorite. Simple. So what about Pluto? Everybody always asks about Pluto. For decades, it was our 9th planet. But back in 2006, astronomers came up with a new definition for what a planet is. And while Pluto orbits the sun, and it's round, it fails one of the new rules. It hasn't cleared its orbital path of other objects. It shares its space with a ton of other icy bodies. So now it's the most famous member of a whole new category, the dwarf planets. So we've toured our local system, but to really finish our journey, we need to zoom all the way out. It's time to get a real sense of our place in the grand cosmic scheme of things. As vast as our solar system feels, it is just one tiny little speck of light inside our home galaxy, the Milky Way. Just think about that for a second. Every single star you see in the night sky is another sun, just like ours, and it probably has its own family of planets too. Whoa, now this is a mind-boggling number. 225 million years. What on earth could possibly take that long? It's not the age of a planet or a star. No, it's something much, much bigger. This is a galactic year. That's right, just like the Earth orbits the Sun, our entire solar system is orbiting the supermassive black hole at the center of the Milky Way. And one lap takes about 225 million years. The last time we were in this exact spot in the galaxy, the very first dinosaurs were just starting to show up on Earth. And that brings us to our final thought. The Sun itself is about 4.6 billion years old. So here's a little cosmic math for you. How many of these grand galactic laps has our solar system already completed? It's a question that really puts our existence, our history, and our future into a truly astronomical perspective. Thanks for joining the tour.